All right, this lecture covers an extremely important concept called database normalization. And it's a little bit nuanced, a little bit tricky to wrap your head around at first. So I want you to rewatch this video as many times as it takes until you really feel like it sticks. So the definition of normalization, it's the process of organizing the tables and columns in a relational database in a way that reduces redundancy and preserves data integrity. So a lot of fancy words there. Basically, it's commonly used to do three different things. First, to eliminate redundant data, which decreases table sizes and therefore improves processing speed and efficiency. Second, it helps to minimize errors and anomalies when you're making data modifications like inserting rows, updating records, or deleting records. And then third, it helps to simplify queries and structure the database in a way that enables easy and meaningful analysis. So makes sense, but it's still a little bit vague at this point. My rule of thumb and my trick for remembering what normalization is all about is that in a normalized database, every single table should serve a distinct and specific purpose. So for instance, you might have one table that only gives you information about products based on a product ID. You might have a second table, which is only your date fields or your calendar. A third might just be transactional records by day, and then so on and so forth. You might have a customer table, a store table, a region table, and these should all sound pretty familiar because these are the types of tables that we loaded up with Power Query and that we're going to use to build this model. So let me visualize this for you to help really hammer the point home. Let's say you've put together a table like this. Now it looks fine, but when you look closely, thing is you've got transactional data here in the first three columns. You've got transactions by date, by product ID, and then the actual quantity sold. So there are multiple transactions by day and multiple transactions for each product ID, which makes sense if products are sold multiple times. Now, on top of that, we also have these four additional columns which provide more information about the product based on this product ID. So this is pulling in information about the brand, the product name, the product SKU, and the product weight, which is fine. There's nothing inherently incorrect about doing this. The data itself is accurate, but the problem is that when you don't normalize a table and you end up with something like this, you'll see that all of these duplicate product records show up anytime the product ID appears more than once in the transaction data, which is going to happen quite a bit unless each product happened to only be sold once. So you end up with all of these rows that repeat the same information over and over and over for every instance of the product ID that shows up in your transaction information. So by creating something like a product lookup with a unique list of product IDs and the associated information for each individual product ID, we can essentially eliminate all of these duplicate records and create a relationship between just the transaction table and the product lookup. So that's exactly what we're going to be doing as we build out the data model in this course. So you may be thinking, it doesn't really seem that critical. This table is still correct. It's giving me the information I need. But the thing is, minor inefficiencies now can become major problems as databases scale in size. So that's your intro to the concept of normalization. Again, this is a really critical concept, so make sure to review this as many times as you need until you're feeling really comfortable with it. And then once you're feeling good about normalization, we're going to move on and talk about data tables versus lookup tables.